Everyone, it's September 29th. All right, let's do it. Design a stack with increment operation. Design a stack that supports increment operations on its element. Custom stack. Initialize object with max size. Push adds X to the top of the stack. The stack has now reached the max size. Pop pops the top and returns the top of the stack or the top of the stack or -1 if the stack is empty. Increment increments the bottom k elements of stack by val. If there are less than k elements, the stack increment all the elements in the stack. I think this is very much is that BIT, binary index tree. Is binary index tree, well, what it does is when you increment, it'll increment the remaining, like it's usually used for prefix sum, right? And because you add 1 and then the remaining will all add 1. Is this what we are hoping for? Actually, it's not, because it's every single one need to add 1. Maybe we can do a segment tree. Yeah, it doesn't feel like segment tree is necessary, because its segment is just everybody in the front, everyone need to add 1, or it's lazy, right? Lazy segment tree. But no, I feel like there's a better way to do this, for sure, right? For sure. So we need to increment the bottom k elements. Okay, bottom k elements. Now, what we can do is basically, let's see if we can have some algorithm to handle. So currently what I'm thinking is, if I say, right, bottom k1, we say we plus 1, and then n is only increment, okay, there's no decrement, right? So say 0, k2, right? So k1, k2, so eventually we will have a list, right? k0, k1, k2, I know, km. So we call m times of this, and we have a history, right? We have a history of this. Actually, no, we have a history of this. This is also not gonna work, because if I do add or minus, and if we don't realize which one has been incremented, okay, so yeah, we will add. So every time when we push, we add a value to it, it doesn't really matter. Oh, it does matter, because if, okay, we can know the length, right? So if k is larger than length, we can just clip it to the length, right? That's fine. So add is fine, right? Add is fine. It won't affect. Pop. If I pop, yeah, if I have a k is adding, let's say, the full length, right? And then I pop it, and then I add another one, and then I pop that one. See, this is where we are going to have problem, right? So like we push one, and then we increment to the end, right? All the way to the end. So this one should be pushed, and then we decrement it, and then we pop it. So this one get popped. I check, so it should increment, right? It should increment. Okay, so far so good. But then what happens is then what happens is if I push again, then we carry this history, right? This position gets incremented, and then when we pop, again, this pushed one will carry the previous history, and it will get incremented, which it shouldn't. Let's think about BIT again, okay? So BIT is, if you add 1 at this position, right, and if you do sum, prefix sum, then all the remainder value will add 1. But it doesn't really tell you individual values. So what else can I do? Bottom k, and I can just go to bottom k and then do the increment, but then it will take times k. I feel like it's gonna time out, as k is 1000, and I get a 1000 calls. So, you know what? I think because it's a medium question, a naive solution probably will work, right? A naive solution probably will work, but I'm not sure if this is something that we want to do, because it's fairly certain that this is not going to be the solution, because what we want is, it is a prefix sum, right? It is a BIT, but on the k itself, because we just need to know from the start to k. Oh, it's actually the reverse, right? It's actually the reverse. Is that the front will have, yeah, but it keep, like I said, it keep a history. It's going, like, if we keep popping. No, what if we pop it, right? I know the current position and I pop it, then I decrement it at that position. How about that? Probably. Now, there's also another thing, is we can count. We know how many increment, because they only increment by 1, right? Which means all the way to k0, everybody add 1. All the way to this, everybody add, no, at k0 we add 1, at this we add 2, right? At here we add 1, like this we add 1, but this we add 2, and this we add 3, and with 0 is the front, right? So, okay, so if I can have a sorted array, yeah, we can have a sorted array. We have something called a, yeah, we probably have a sorted array, right? Okay, so we have a sorted array, and start with 0, and k, I think, has to be 1, right? So we start with 0, and then every time we do a k, we do this, right? We put a k in, and we'll clip it at the current length, all right? And every time we push, it's fine, but every time we pop, right? Every time we pop, so the k, current k, will not be bigger than the length of the, and I can also have a situation where we cannot push. Yeah, so we also need to consider that. But what's important here is after we push, we'll always make it bigger than this, right? So yeah, it's fine. It's when we pop, right? When we pop, if the top of this k is smaller or equal to the length, then we're fine. That we don't have to worry about anything. If it is equal, right? Yeah, that's the situation. If it's equal to the length, if I pop it, right, then this one has to be popped as well. Right, this one has to be popped as well. And yeah, this one has to be popped, and I need to push in the same value as the current maximum. Right, that's what I need to do. Yeah, and every time, yeah, you know what? This is actually not that bad. Every time we pop, because all I need to know is every time I pop, right? Oh, probably a priority queue will work. I think a priority queue will work. Wait, hold on. Think again, right? Think again. Every time I pop, right? If I have incremented, yeah, let's say we have someone at the beginning. Yeah, someone at the beginning won't be popped until at the very end. So every time we pop, we'll pop the current one, and then we'll append a new one, which is, you know, the previous increment, right? Yes. So now I maintain the same number of increment for the previous values. So I keep doing until we hit a situation. What situation? Until we hit a situation where there's no such situation. Like we will have to keep track of all the increments, right? Because you increment and you increment and you increment. Every time you increment, the values at the beginning will get add 1, and we'll add 1, and we'll add 1, right? And they will keep adding 1, so you have to keep piling up. Those things don't get removed. It will never get removed. It will remain in there unless you pop all of them. Because every time you pop, you're using the current amount, right? Yeah, every time you hold on. Every time you pop, it is going to be the number of actual length that it has. If you have one of them, then you get increment once. If you got two of them, you get increment twice, right? And you pop all of them. That's the thing, right? You need to pop all of them. And you just count how many times you pop. That's how many times you need to increment. I think so, because you just keep, yeah, so we need a priority queue for that, and then you just keep popping the ones that has the same value as you. And if the top is not the same length as your current, then it's not going to work, right? You're not getting incremented. Okay, yeah, we have a design. So here is the design. The design is we need a list of integer for stack. I think we can do stack. Can I use this? There we go. So we have a stack and max size, it's fine. What else do I need? I need a priority queue. Increment marker, inc markers. think we need to do AB and integer compare A and B. Okay, so that's that. All right, so we shall do this dot max size equal to max size. That's it. All right. Push. If stack dot size is smaller, is equal, right, to this dot max size, return. We don't push. Otherwise, stack dot add x, right? Pop. If stack dot is empty, return -1. That's what I remember. If the stack is empty, right? If not empty, then we need to pop, right? We need to pop. So we can set, we pop it first. So int p will equal to this dot stack dot pop. Okay. So now it will be interesting. Actually, I think I need its length. So increment amount, right? I'm gonna say while this dot increment markers dot is empty, right? If it's not empty, and this dot inc markers dot peak is equal to this dot stack dot size, this dot inc markers dot pop pull, right? It just means if the top is, oh, actually we have one more thing to do, which is we need to plus inc amount plus. So we want to know how many times we need to increment the current value. So we check the increment markers. How many of them has the same size as the current one, right? Yeah. And don't you have another thing that you need to, every time you pop one, you have to add one back? Yeah, hold on. So now we have the top is the same size, which means, yeah, we're keeping track of how many times we need to increment. So we pop all of them, right? We pop all of them. So, and then we have something smaller, which means it doesn't include the current one. But what about the other thing that you were thinking about earlier, where you pop one and you have to add one back? What's that about? Well, what it's about is I increment, okay? And I pop one, and when I pop one, all the things, so they got popped, right? No, I think this is. I don't see there's another requirement here. Right? It's like we say increment this, increment that, increment this, right? And as I pop the top, if we doesn't have anyone, then yeah, we don't do. If we have something, yeah, we don't. That's it. I think that is it. You pop something. Wait, hold a second. What we're saying is if we have a up until here, and then k up until here. So all of these need to be increment once, right? And every time when you pop it, yeah, you have to add it back, because we have something. Yeah, let's say, hold on. Wait, I'm a little bit confused here. Let's say we increment markers, right? Let's say increment markers is 0, we have 5, and we have 10. 10. Okay, that's the increment markers, which means at the length 10, right? This is the length 10. When this one gets popped, so like everything, this is 5, this is 10, right? So all of these get increment 1, 2, 3, 4 times, right? These have to be increment 4 times. Everybody here need to increment 3 times, right? And then when this get popped, I I do 3, and then I need to push 3 back at 9, right? I have 9 because next time I pop here, I have a 9, right? So I have to pop 3, add 3 back, pop something, add something back, pop. Yeah, same thing. If I pop this, I have to add them back until, like, if I only have 1, and then this shall be have like 4 ones. I'll pop all of them, right? And then I'll add 0 back. But we don't add 0 back because there's no point adding 0 back. So we do have to add it back. So we do the increment amount, right? We do the increment amount, and then yeah, we pop the p. So int p, we can say int res, the thing we need to return, shall be this one plus increment amount, right? It shall be plus increment amount. And then we shall say for int I0 I smaller than increment amount I plus plus, we shall say this dot inc markers dot add what? This dot stack dot size. We need to add that many number of times. Now here is a thing. We can do this with just 1, right? So if we don't do this just an integer, if we do it as, position and your value, right? So if we do it something like this, right? If we do it something like this, let's say we do it this way, and we compare A0 and then B0, right? Which element is the marker and the frequency, right? So if we do that, then we'll say if it's not empty and the peak 0 is equal to, so yeah, we basically, we don't have to do all that because I know the increment amount, right? I do know the increment amount. So all I do is I check, right? I check increment amount shall equal to we'll say this. If it's not empty and 0 is equal to the size. If this is true, right? If this is true, then increment amount is equal to this dot inc markers dot poll 1. Right? We just get its amount out. Otherwise, it is 0. This is the increment amount, right? Increment amount. So now we get increment amount, then we'll get the result to return. Okay, this, when we pop. So the next thing we need to do is we need to check, right, if it's not empty and ink markers.peak 0, peak 0 is equal to this dot stack dot size, right? Because I stack already pop one, so this is the next one we need to add. So if it's equal to the size, then this dot ink markers dot peak 1, right, plus equal to ink amount. Else, if it's already empty or the peak is not equal to the size, then this dot ink markers dot add new int this dot stack dot size and ink amount, and we'll return res. Okay, so now we're gonna increment. Okay, we're gonna increment. So I'll increment k. Oh shoot, val. It's not increment by 1. I think it's fine. Yeah, I think it's fine because this design supports that. It's just increment by val, right? So we will add k. So first of all, so k shall equal to mass dot minimum k and this dot stack dot size. So I have to clip it at the maximum so far, right? Then I can say, oh, then I need to know. Holy crap. Holy crap. Yes, that's fine. This dot ink amount, ink markers dot add new int. So basically we will do k with val. Yeah, k and val. And that's it. And then here we have the change. Right? Here we have change. Okay, ink amount equals 0. While this dot ink markers dot is empty and this dot ink markers dot peak 0 is equal to this dot stack dot size. If these two are the same, ink amount plus equal to this dot stack dot not stack ink markers dot pull 1. Okay, so yeah, we do this because if we might have duplicates. So we just do that, pull, 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 pull. If it's the same, we'll pull and we add, pull, we add, pull, we add. And once we're done, we get out, right? And I have ink amount. We'll do this, which is fine. And then we'll say, again, the same thing. If the next one is equal to the current, then we will, yes, do that. Because we compress the previous one. And the next one, we can just do this. It's okay if we have multiple. We at least get one of them correct. Otherwise, we'll do this and then we'll return res. Okay, so that is kind of the idea, and we'll see if it'll work. Oh my lord, it's terrible. Why is it not getting add anything? I call increment. I call this dot stack dot size. Yes. And add new. It's basically size and a value to add, right? Oh, I think it should be a. Damn, I think it should be a max. Should be a max heap. I did it a main heap. There you go. All right. Okay, so let's change this to a max heap. Yeah. So this should be. Oh, what did you do, man? This should be B and this should be A. Use a regular stack to keep track of the actual values in the stack. Use a max heap to report which bottom k values need to be incremented by what amount, right? Now each time we need to, so push is straightforward. So actually, I mean, push and increment, right? So both are straightforward. Push and increment are both straightforward with no fancy algorithm. The trick happens in the pop function. Now when we pop, we need to know how much increment the popped value need to pop value has been subjected, right? Has been subjected. Now we look into the max heap, right? And accumulate all the well, except the increment need to clip k such that it is not bigger than current size of the stack. We look into the max heap and accumulate all the increment with increment whose k is the same as the current size of the stack. Any math? Whose k is the same as the current size of the stack. We pop these increments. Yes, I'm coming. I should have a lovely, gorgeous, lovely Where are we? The same as the current size. I pop these increments, but then we must add them back, right? With and pop the current stack. But then we must add the popped increment values back to the max heap, right? Back to the max heap and merge with and create or merge with the element with the same k as the current reduced size of the heap of the stack. Yeah. Oh, and when it's 0, we don't do it, right? Yeah, so if stack is not empty, right, if the stack is not empty, then we do this. Right, if the stack is not empty, then we need to do the increment markers. But if the stack is already empty, then those extra increments that we have is basically useless, right? We don't do those anymore. Okay, so let's try run this and maybe try another test case. For example, this is a push, push, pop, push, 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 increment, increment, and all pop. So yeah, and then if I push again, and then I increment, and then I pop. Okay, so I'll push again, still push this, that's to push 100, increment 100 with 100, and then pop. Okay, looks good. All right, let's try this. Yep, got it. Pretty good. I think we got this one right. All right, check the solution. Array. O1 for push and pop. OK for increment. It's seriously, it just does this. And I was trying to think, this is O log k, right? This is every time is a log k. So O log k and O log k for this. Linked list O1, OK. Yeah, lazy propagation. O1 for all operation. All right, we have some mind-boggling stuff here. How do you do this? Yeah, that's why I use this. Why we use this. Lazy propagation. Uh-huh. Tracks the increment values. Each index I will holds a cumulative value. Ooh, cumulative values by which the element 0 to I in the stack will be incremented. Okay. Push, pop. You know what, let's just read the code. Probably will be easier to understand. This is a stack. Oh, and we can use index, right? Yeah, that's all right. Increment array. That's the increment. How do you do increment? Increment index plus equal to val. Okay. Calculate the actual value with increment. So we get a stack value and plus increment array top index. If top index is larger than 0, propagate the increment to the element below. You just propagate it once. Oh, what? Damn, you propagate it once. Okay, I admit I did not realize you can just propagate it once. I thought you have to propagate all of them. Well, technically, yeah. You do need a top index, I agree, because top index will make things a lot easier. So you have a top index, and when you pop, you do the top index, but if it's a 0, yeah, then it's 0. So just every time an increment, right, you set whichever, yeah, you have the increment position, just keep the value there, right? Keep value, keep value, keep value. And when you pop, you go from right to left, right? So every time you pop, you are passing your value down. So it's exactly the same idea that's here, right? So it's the same idea, like we just add the increment amount, but instead of using a priority queue to keep track which one you need to increment, we're using an array, and we just simply move one stop. Oh, this is better. Oh, this is much better. Holy crap. All right, I have no argument that this is a much better solution. A lot better. I would say they are the same idea, because I did not even bother go through the first two approach, because I know it's going to be suboptimal, right? It definitely is going to be something better. So this is a better solution, much better solution. So first of all, stack and inc markers. I still call it ink markers, okay? And index, top index. Yeah, we can set it to -1, that's fine. And we can say this dot stack new int max size, this dot ink markers, same thing, new int max size. Right, so another thing I need to just keep this. Yeah, this solution has the same idea, has the same idea. This solution is the official, right? It is the official solution, and it has the same idea as mine. However, it has a much smarter implementation of keeping track of how much increment each popped value needs to be added. It propagates the incremented amount just like I did, but it only does it once, right? Only does it once without ever having to loop. Also, since we use an array instead of priority queue to keep track of the ink markers, the operation of maintaining and using ink markers is O1 instead of O log k. Okay, let's do push. If top index, because I know +1 is smaller than this dot stack dot length, we say this dot stack plus top index is equal to x. This is a push, right? An increment is also easy. We just say k shall equal to math.minimum k and this dot stack dot length and this dot ink markers k minus 1 plus equal to val. Right, there's a clipping. Now pop. If top index is smaller than 0, yep, return -1. Otherwise, okay, so we have the top index we need to do, so we can say ink amount, yeah, this dot ink markers top index, right? We get the thing, and interest shall equal to this dot stack. Actually, we can do that at the end, and then we need to propagate. Okay, how do we propagate? If top index needs to minus, so we can do here minus, right? I say if top index is larger equal to 0, and this dot increment markers top index plus equal to ink amount. So we just propagate it back, and we return this dot stack. Oh, we can say, Okay, we don't do this. We do this. If the -1 is logic is 0, and then we say this is -1, and then this stack minus my top index minus minus plus inc amount. That's it. Very, very simple. It's almost like a crime. It is almost like a crime. I think I know where it goes wrong. And then this dot inc markers top index need to reset to 0. Yeah, we need to reset to 0, and that should be fine. If we reset to 0, yeah, then it'll be fine. We reset it to 0, but it's not fine. Why is that? Oh, because of this. I'm going to say I equal to k minus 1 and top this the top index. It didn't even say this on all the top index. God lord, man. I didn't have a good habit to say this. 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 Right, k minus 1 and this the top index. And I can just do this. That should be fine. Right. There we go. Ooh, -1. Ho, ho, ho. We got a problem. Got a problem. Ah, what? So it has to have something. So this dot top index must be larger than 0. So if this is larger than 0, then we do this. There we go. Oversight. That is the solution. That is the solution. Much faster. Yeah. Okay. Good. Yeah, that will be it. I'll see you guys tomorrow. Adios.